Hello and welcome. So we're told we have a 9-inch by 10-inch rectangle inscribed in a circle as shown below. So inscribed just means that you have a circle. Whoops. Oh, weird thing off to the side. Okay, you have a circle and inside of the circle is a rectangle. Now the reason why we care about using the word inscribed here is that means that every one of these little vertices on your rectangle is hitting directly on the circle. These are points in your circle. Okay? So that's what we really care about, is that it looks like the rectangle is hitting the circle, and being told that it's inscribed literally guarantees that it actually is. Okay? And then from there it says what is the area of the circle. So it's not just finding this, it's not asking for this like blank space between the rectangle and the circle, right? It's asking for literally what is the area of the whole circle. You say, okay, well, first off, what's the area of a circle? What's that formula? Hopefully, this is one you gotta know by heart, right? You'll use it so often, and that is area equals pi r squared. Okay, where r is your radius of the circle. Right, so alright, well, if we want to find the area of a circle, we have to know its radius. Well, how do we find a radius? What even is a radius if we even have to ask that question? A radius is a point that goes from the center of the circle to the outside of the circle. Okay, that is your radius there. So I'd say, alright, well, any point from the center to the outside of the circle. Does that just mean that if we take 10 and if we take half of that, is that the radius? No. Because would you, hopefully, let me use a different highlighter to kind of make it obvious. We said that the radius from the point center to the circumference, right? And if we use 10, is that the same distance? No, right? And even shorter distance from that would be that blue distance. That's clearly not going to be a radius either, so taking half of 9 isn't going to get you what you need either. Well, how? How does it make sense then? How can we find our radius? Okay, get a little fluid with your thinking on this one. We know that anywhere from the center to the outside is a radius, right? That's a radius. This is a radius. That's a radius. And this is also a radius. And this is going to be where the magic happens. We know that a point to the vertex of the triangle, sorry, not triangle, of the rectangle is a radius. What if we did a radius to the other side too? This is what we call a diameter, which is from one side of the circle to the other, crossing through the middle. Well, what do you notice that just made inside of your circle? A triangle, and because you know it's a rectangle, that means that there is guaranteed to be a right angle there. And we know for any triangle, if it is a right triangle, specifically meaning that you have a right angle in there, you can use what's called Pythagorean theorem. And Pythagorean theorem essentially says that if you have a right triangle with legs A and B and hypotenuse C, then your Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. And this is where the money is kept right there, guys. Alright, so that means that now we have our two legs, right? We have legs 9 and 10. So we take leg squared plus leg squared equals our hypotenuse, I'm going to call d squared. And the reason why I'm calling it d is because that is the diameter of our circle as well, right? That doubles down as the diameter. So that would be 81 plus 100 equals d squared. 81 plus 100 is 181 equals d squared. And how do we get rid of squares? Square roots. So we take the square root of both sides. Now remember, when you take a square root, there's technically a plus or minus, but if we're talking about lengths, can those be negative? No, right? It doesn't make sense to have a negative length. It's going to be a positive one. So while there is a plus or minus, don't worry about the minus there. Okay? And now we have d equals the square root of 181. Well, we're practically there. Okay? Because now as you look at this, now you can ask yourself the question. Alright, so now we have the diameter. The diameter is not the radius, right? In order for the area formula to work, we need the radius. How does a diameter relate back? Again, the diameter is the whole orange line, right? It's the whole thing. And the radius is just half of it. So in order to find the radius, we take our diameter and we half it. Well, the diameter is square root of 181. So we just take half of that. Booyah. Okay? And I would literally just plug that right into our area formula. So if our area equals pi r squared, and we now know that our r is that square root of 181 over 2, plug it in. Okay? So then we end up with pi times square root of 181 over 2 squared. Now the reason why I didn't even bother trying to simplify that 181 is you'll notice at this point, then we'll end up with a square and a square root, right? This is the same thing as 181 over 2 times the square root of 181 over 2, right? Squares mean you have two of the same thing. So when we multiply these two fractions together, what's a square root times the square root when they're both the exact same number? It's just that number. 181 is going to come out. Because we know that if we have two of the same thing, one is going to be able to come out of the square root. It's going to be able to simplify out. Which means that now we have that. In our denominators, we have 2 times 2, which is 4. Okay. So now we know that we have that square root of 181 over 2 squared is the same thing as 181 over 4. And now we have 181 over 4 pi. Now, none of these are those answers. But we do know that if we kind of try to simplify it more, we can get closer. So if we do 181, whoops, let me try that again. 181 divided by 4, we get 45.25. That means that this is the same thing as 45.25 pi. And which one of these answers is close enough to that one? Right here, this one. Alright, 45 pi is really, really close to 45.25 pi. Alright, then there you have it. That's literally going to be it. That'll be your answer, and there's nothing more that can really happen. Okay? Alright, thanks for watching.